Page 606, problem 11a. This is a base ionization. You're told it's a base ionization, which tells you that whatever they give you is a base. So, if it's a base, what do Bronsted-Lowry bases do? They are proton acceptors, which means the water is going to be giving up a hydrogen to the base, and water now is going to act as an acid. Remember, water is what we call amphoteric. That's spelled A-M-P-H-O-T-E-R-I-C. Now, just like the acid ionization, water is going to be considered a liquid, and this guy is going to be aqueous, and we are going to go ahead and figure that this baby is our base, making this the acid, and now we're ready to go. What is this going to look like when it gains a hydrogen? It's going to be a C6H13 and then an NH3. Whoops. Yeah, NH. There we go. That's an H. A little messy. But the subscript is going to be 3 on this guy. Notice these H's right here. These H's stay, just like in the acetate ion. The C2H3O2, 1 minus, acetate ion. Those hydrogens in the middle never go. They always stay. They're part of that formula, or they're part of that ion. This is another ion. This is one ion. This is our second ion. And this guy ionizes even further to give off one of the hydrogens. So we're going to go over here. This guy looks like a 3, and he is going to be a 1 plus. Okay, because he accepted a proton. That proton made him more positive because it didn't drag along an electron. Likewise, when the proton leaves the water, what does that leave? It leaves the OH, 1 minus. And you may want to consider for all of these kinds of equations that water could be written this way. And if that helps you, write water that way, because now you see it's going to lose the hydrogen. It's going to go to this guy, leaving this hydroxide all by itself. And that's what you're seeing over here. So now we have this guy that just got the hydrogen, and now he's a little positive, and he has a hydrogen that he can give away. And so he is going to be now our conjugate acid and the conjugate base. So let's tie them all together. The base, when it gains an electron, becomes the conjugate acid. The acid, when it loses the electron, becomes, not the electron, I mean the hydrogen ion or the proton. Let's say that one more time so you're not confused here. This guy is gaining a proton, he becomes positive, it makes him the conjugate acid. This guy lost the proton to this guy, and so on the other side, we're looking at what's left, and that's the hydroxide ion, and that is our conjugate base. Now, let's do the K sub B. K sub B is the equilibrium constant of the base. And just like we did with the acid, we're going to put our products on the top, and we're going to put our reactants on the bottom, but water is not part of that, as it never is part of equilibrium when it's in the liquid state. So we're going to put our C6H13 NH2 in brackets to represent the concentration, and this is going to be an H3 and a 1 plus. We're putting this guy, because he's a product, into here. So that's our first product. Our second product is the hydroxide ion, 1 minus, and the only reactant is the C6H13 NH2. And this guy is in brackets. This equation happens to be balanced. I didn't work it out for you, but these equations tend to always be balanced without using any coefficients. So there become no exponents in the equilibrium for the k sub b. And that's the way you should do problems B, C, and D. Good luck. Bye-bye.